So this is the homework assignment I gave you guys tonight, and I know this is pretty tough stuff. Okay, we're making a lot of connections here, and I think one of the hardest things about this lesson and this content that we're in right now is that there's so many options. There, like when you're looking for an answer, there are so many different ways to get to an answer. Sometimes we like it better when you just tell me, hey, here's this one thing you can do to get to an answer. So I thought that maybe I would work through this first problem with you, okay? Just so you can kind of see what I'm looking for and see where you have some choices in how to do these problems, okay? So our goal here is to take a polynomial like this one, all right, and find all of the factors and all of the zeros. Now that sounds like a lot, but remember that every factor gives you a zero, and every zero gives you a factor. So really, if you can find one, you have the other, okay? So here's what we're going to start with. The problem with this right now is that it can't be factored the way it's written. Okay, there's nothing that we can pull out of this. There's no grouping that can go on, nothing like that. So I'd really like to get this to the point where it's a quadratic rather than an x cubed. And I have one of the factors already. So what I really need to know is what would I multiply this x plus 5 by to get back to this thing? I want to know x plus 5 times what, this is what I'm trying to find, would give me this polynomial back, okay? And I can find that using, I could do long division if I wanted to, or I can do synthetic division, which was the new thing I sort of threw at you today. So to do synthetic division, you want to ask yourself, what is the zero that corresponds with this factor, okay, or the root, however you want to think about it. But if I have a factor of x plus 5, the zero would be negative 5, right? Because negative 5 plus 5 would give me 0. So I'm going to put negative 5 in a fancy little box here, okay? And then what I'm doing now is lining up the coefficients from this polynomial. So I'm going to do 1, and then 9, 23, and 15. Do keep in mind a couple things about synthetic division. If you're missing any pieces, make sure you put a 0 there, okay? Yeah, I think that's everything for now. So I'm going to draw a line, leaving myself some space here, okay? And now what I'm doing, I'm going to drag down this first one and just put a 1 there. Now I'm going to multiply. Negative 5 times 1 is negative 5, and that's going to go right here, okay? And then I'm adding together up and down. So 9 plus negative 5 is 4. Now repeat. Negative 5 times 4 is negative 20. Add together with this one, and I get positive 3. Negative 5 times 3 is negative 15, and when I add that to the regular 15, I get 0. And that's good, because this thing down here on the end, that's really my remainder. Okay? And if we know that this is a factor, then I shouldn't have a remainder, all right, because it should divide in perfectly. So this 1, 4, and 3, what that's really giving me is the coefficients for my answer to this question, okay? And because I started with an x cubed up here, the largest degree I'm going to have here is an x squared. So this is really giving me 1x squared, or just x squared, plus 4x plus 3, okay, as the answer to this question, okay? If I take out the x plus 5, this is what I'm left with, okay? Now, I still don't have the factors or the zeros because this by itself can be factored further. So now I have two choices, okay? This is where my choices come in. This one does not look too bad to just go ahead and factor myself, right? X squared plus 4x plus 3. And this is what I meant when we were doing all that factoring before, where I said I want you to get really good at factoring, where it's like an easy thing to do. Because I can take this thing and factor it as x plus 3 times x plus 1. And I know that works because 3 times 1 makes 3, right? And then if I were to multiply the inside and the outside, I would have 3x and 1x, which gives me 4x, okay? So to recap here, what we just found out is that if we wanted to factor this entire thing, it would look like this. And I'm writing over here because you guys only had to do the odds, so you can use this space if you want to. My factors look like this: x plus 5, and that came from here, times x plus 3 times x plus 1. If I multiplied those three factors back together, I would get back to this original, okay? So that's my factored form. And then if I want all of the zeros, remember I'm asking myself, if I were to set this equal to 0, what would I get as an answer? If I was to set this equal to 0, if I was to set this equal to 0. So my zeros would be -5, -3, -1. Okay, those are my zeros. Okay. To double check for myself, if I wanted to, I could go into my graph. I'm going to get rid of that, and I'm going to graph that original thing. So x cubed plus 9x squared plus 23x plus 15. Make sure I'm on a standard window here. And really what I'm looking for is, are these the three places where this thing crosses the x-axis? So there's -5, there's -3, there's -1. Okay? So that's what I'm trying to find here. Okay? Now I had mentioned some choices here. If you had wanted to, when you reach this quadratic, okay, and this right here, this is kind of your goal, is to get to the point where you're at a quadratic. This was an easy one for me to just factor myself. But my other option would have been, I could use the quadratic formula on this thing to find my zeros first. And that's easy if you have the quadratic formula in your calculator. So in your calculator, if you've got the program, I hit the program button to get here. I'm going to choose quad for quadratic formula, enter. And now I'm entering my coefficients from this one. So really I'm entering the 1, the 4, and the 3. 1, 4, 3. Oh, that did not work like it was supposed to. I may have something wrong with my program here. Yeah, I'm not going to do that here on the video, but okay. What should have happened there? Sorry about that, guys. Something's wrong with my program. When I did the quadratic formula here on this guy, x squared plus 4x plus 3, I should have found -3 and -1 as my zeros, okay? And once I had my two zeros here, I could then turn those back into the factors. So it doesn't matter to me whether you find the factors first and then find the zeros, or whether you find the zeros and then find the factors, okay? Either way, this is what I want to see as part of your answer, okay? So you're doing that for 3, 5, 7, and 9. On number 7, just be careful when you set up your synthetic division. The 0 that goes along with 5x plus 1 is -1/5, also known as -0.2, okay? That's okay. You can still set up your synthetic division with that number, okay? And then fill out your coefficients here like you normally would. Do all of your math. You may end up with some ugly decimals and stuff in here, but your answer will still come out to give you a quadratic like it did here, okay? Okay, that's really it for me here. Let's just see. And then here on the back, 13, 15, and 17, I would do this the exact same way. The only difference is they don't really care about the factors here. They only care about the zeros, okay? You could still find that by factoring. You could still find the factors, but as far as your answer goes, all you have to do are these numbers here, okay? You don't have to list the factored part of it, but otherwise, process is the same, okay? Okay, hopefully that's helpful. I'm going to go try to figure out what's going on with my program here, and we'll touch base tomorrow on this assignment.